Okay, so now let's move along to where it starts getting a little bit hairy. And that is, we're going to start doing conversions now. We're going to start doing some of these so-called stoichiometric calculations. And what we're going to do is start out learning two calculations. If I know the number of grams of a material, I'm going to calculate how many moles of material we have. Or if I know how many moles of material, I can calculate how many grams of material. Again, my relationship, my conversion factor to get me from moles to grams or grams to mole, that is called atomic mass. And where do I get it? From the periodic chart. Right. Okay. The second calculation we're going to do is, if we know moles, we can calculate the number of particles. Because why? We know there's 6.2 times 10 to the 23rd particles in 1 mole of particles. Or if I know the number of particles, I can use that conversion factor to count the number of moles. And so here you begin seeing we can now daisy chain these together, and we'll go over some examples and do what is called stoichiometric calculations. By the way, real quick, the number of particles that we're dealing with. Look, 1 mole of tennis shoes is 6.02 to 10 to the 23rd tennis shoes, just like 1 dozen tennis shoes is 12. Don't get too worked up about it. Avogadro's number is really just a number that has a name. The number 6.02 to 10 to the 23rd is given the name Avogadro's number, just like the number 12 is given the name dozen. They're interchangeable. For whatever reason, we choose to give some numbers names and other numbers we don't. Avogadro's number is one of them that we do. Right. Stoichiometric calculations in general. The best thing to do is just to consider the concept of mapping. So by that, I mean you're going to use dimensional analysis and you're going to use a map at the same time. And this will help get you started. For example, let's say that I am wanting to calculate the number of particles. Anytime I'm going to calculate something, I normally box it. And I'm given the number of grams. I put a star there for start. It's kind of silly, but right. Start, S-T-A-R-T. Yes, that's where I'm going to start. So I draw a star there. And then I have a box. Now I'm going to set my dimensional analysis up. Box equals star, and then I do the dimensional analysis. So in this case, I would put how many particles do I get, starting with, I don't know, X grams, however many it said we needed to start with. And then I would just do my dimensional analysis. One more quick comment before I go to the next slide. What do I mean in particle? Even though it could be anything, in chemistry we normally deal with 4 different things. We deal with atoms, we deal with ions, we deal with molecules, and we deal with electrons. Those are the 4 things we typically deal with. Sometimes we jokingly refer to this as amies. So when we talk about particles, probably the best thing to do is how many amies do you get, where an amie can be any one of these 4. There are other things you can use, but these are the big 4. So now you understand where dimensional analysis comes in, where the mapping comes in, where the molar mass comes in, and where Avogadro's number comes in. And now what we need to do is practice pulling those all together. Okay, let's now work through the first problem. And this is one where we're going to go from grams to atoms. In other words, what we just saw a minute ago, we know we can go to grams to moles, and we know we can go from moles to number of particles, amies in this case. If we can go to number of amies, this time we're talking about atoms, so we're going to talk about the number of copper atoms in particular. So let's start out. The first thing we want to do is draw our box and our star, because we need to know what we're doing here. So we're looking for how many copper atoms. Okay, so if we're looking for how many, that's going to be this number here, how many. That's our box. Our star is going to be what we know, what we're given. So this is where we're going to start. We know we're going to start with 5 grams. So there's our star right there. So now we're just going to map. There's our box equals star. So let's start out. Our box is how many atoms of copper, and our star is 5 grams of copper. And now we're just going to use dimensional analysis to take us from here to here and from here to here. So I can see right now my end result. I'm just going to need 2 conversion factors. Why? Because I'm only taking 2 segments of my path here. Okay, so the first thing I need to do is go from grams to moles. So let's set that up. I'm going to go from grams to moles. Okay, what do we call the conversion factor between grams and moles for any material? That's called atomic mass. That has the symbol A. And where do we get it? We get it from the periodic chart. So if you look at the periodic chart for copper, you will see that A is 63.55. So now we've gone the first step. Notice our unit left right now is moles of copper. So that means in our path we have now moved and we are now here. We have but one more step to do and to go from moles to number of atoms. Well, there's only one relationship between moles and number of anything, and that's called Avogadro's number. And where do we get it? Well, that's basically memory. That's a constant. So we remember that there's 6.02 and 10 to the 23rd atoms in 1 mole of atoms. Now, we could have used this conversion factor either way. Why did I put the moles on bottom and atoms on the top? Easy, because moles is not in my answer, and so moles has to go away. The only way to get moles to go away from the top is to put it in the bottom. Notice that the only unit that I have left standing at this point is what? Atoms of copper. And what am I looking for? Atoms of copper. At this point, I'm ready to pick up my calculator, and no point before now. At this point, I now have the signal that says time to pick up your calculator, and that is the unit on the right side of the equal sign is exactly equal to the unit on the other side of my box. And when I pick up my calculator, I multiply this out and I get 4.7 times 10 to the 23rd atoms of copper. One more note about that. How do I do that calculation? It's very easy with dimensional analysis. Anytime a number is in the top, you precede it with a multiply sign. Anytime a number is in the bottom, you precede it with a divide by sign. So some of you might do something like this. You might go 5 times 6.02 and 10 to the 23rd divided by 63.55. That's okay. Or you could do 5 divided by 63.55 times 6.02 and 10 to the 23rd. It doesn't matter what order you do, multiplication and division or commutative. All you have to remember is if the number is in the denominator, precede it with a divide by sign. If the number is in the numerator, precede it by a multiply sign, and you will have it.